Next section concerns the implementation of inheritance mechanisms in C++, so the first part of inheritance in C++, as it were. Up until now we've seen what inheritance is: generalization, specialization, scenarios, the is-are relationship between, we call them base classes and derived classes. Base classes are the more generalized classes and the derived classes are the more specialized classes. The big question is how do you do it in C++? We know how to do it in our heads on paper, and we know that the relationships are semantically correct, that they actually model something in your own domain of expertise. We want to show how to actually implement it. So the topics are the following. We will always consider the terms base class and derived class and the corresponding objects, of course. The is-are relationship, just a review. When you're creating derived class objects, you have to create the data corresponding to the derived class, but the derived class has two data blocks, as it were: the intrinsic data corresponding to the new derived features, and the data which it inherits from its base class. So a very important issue here is to show you how to implement constructors in derived classes, so creating objects of derived classes, because the data becomes more. So the data in the derived class is really its own intrinsic data plus the data which it inherits from the base class, as I've said just a moment ago. We want to talk about the visibility of base class members. So when you inherit, you get all the functions in the base class for free, provided that you make them public, or maybe some other keyword using. Some functions in the base class we may not like, because we would like to override it in the derived class. We have to override it, or we may. These are the scenarios. The colon syntax, which I've mentioned a few times already in the C++ part of the course, is how to initialize data from the base class from the code in the derived class. So these are the topics, and at the end of the section you should be able to create derived classes and make sure that the constructors have been correctly implemented. Okay, so here we have the colon syntax. We take a non-inheritance example just to start off with. If you can remember, we had a point class, could be a complex number class as well, but a point in 2D has got two member data, the x and y coordinates here. So m underscore means member data, and the default constructor is basically the values are initialized to 0, which is okay. This works fine. So what happens is the following: it's a two-step phase, as it were. First of all, the data member is created, and afterwards the so m is created and afterwards assigned to the respective values, which is fine because you're assigning a double is easy. But these can be big objects, so when you're assigning big objects, you're calling its assignment operator, which we talked about in the operator overloading part of the course. So it's a bit inefficient. An alternative is the following. Let me go down to the example immediately. Instead of saying mx is 0 and my is 0, I'm initializing using this so-called syntax, colon syntax, and I'm initializing immediately. So mx is initialized to 0 and my is initialized to 0. It's like a copy constructor, you might say. So in other words, the copy constructor is he doesn't create the object first and then assigns it to a certain value, as we saw here in the example just a moment ago. It actually initialized the object from scratch, so it's much more efficient. And the advantages are the data member is assigned at creation, so it's more efficient. It saves the extra assignment again, and the constraint is that it only works for constructors, so you can only initialize the data using the colon syntax in constructors. Okay. Another example is here. You've got a circle. You know, the circle has a center point and a radius as member data. So if I want to initialize the default circle, it could be the center point 0 in each coordinate, and the radius of 10. So I just I've got a comma separated list of initial data to be initialized. So M center is 0, 0, so it's a point. So I actually I've got a point constructor with x and y coordinates here, you see. So he's calling the constructor of point immediately. M center is a point object, and the radius is initialized to 10. In general, the syntax is the following. So not only for points, but for your own applications and classes in a moment. In the CPP file, of course, you've got the scope resolution operator here. Here's the default constructor, for example, and its scope here. So it's in class name, colon syntax, and member, whatever member it might be, constructor arguments. So the member data, and you give the constructor arguments. So he calls the correct and appropriate constructor for you. Okay, so we want to talk about the const reference member data. I think I will skip this section because I hardly ever use it, so I'm not going to discuss it, because yeah, you can, if you're interested in it, you can have const member data as well. These are member data which can only be created once, and they cannot be changed anymore. Okay, it's a bit in the 20-80% margin. Okay, now I want to get on to the, having done the colon syntax, I want to get to the is-a inheritance in C++. And in C++ jargon, we always talk about a base class and a derived class. So let me just draw a diagram here, just to help you visualize things. We go through the scenarios now in a moment. So here's my base class. And all classes, you know already, it's got data, D for data, and it's got functions. Derived class is the triangle here, you see. D for derived. It's also got data plus functions. Now, when the normal scenario is you start with a base class, you got a base class with data, functions and whatever, and you create a derived class from it. But in general, the derived class adds functionality with respect to the base class. The derived class is in all respects a base class as well, but it adds new data and new functions. That's what we're going to be going through in the next two sections. So it's always more. Now, and what do I mean by more? The derived class can add extra state, extra member data, extra member functions, which the base class does not have. Otherwise it's not a specialization. What's the point of deriving a class from a base class if it adds no extra functionality? You've also got the following scenario, and there are different sub-scenarios involved here, which we will discuss as we progress, of course. Certain member functions in the base class we are going to override in the derived class. So let me go back to my diagram. What do I mean? I mean I might have a function here called f, any old function. So it's defined in B, and I decide to override it, rewrite it in the derived class. So when I call an object of a derived class, later on you want to know, does it call the f function here in the derived class or in the base class? So certain functions in the base class are going to be overruled, overwritten, override. Okay. Now, how's the syntax? I'm taking a very simple example. Base class called account. So everybody knows what an account is: bank account, bank number, your name, the amount of money in your account, and so on. I want to create a credit account. So credit account is a special account, maybe extra member data like the credit limit you've got and the amount of interest you pay and so on, which a normal account doesn't have. So it's the base class account is like a vanilla flavored account. If I had to draw a UML diagram for the hierarchy, so I've got let me draw it here just to before we jump into code. Here's my account class. let me call it A, and its derived class is credit account. Credit plus other accounts later on. Could be a savings account or something. So the mapping from UML to C++ is the following. I say class credit in my header file for credit.hpp is public account, and I define all my functions here in my credit class. So credit is publicly derived from account. What do I mean by account? All the public member functions, all the public members in account are visible to the code in credit. And secondly, private in account is also private for credit. So it inherits all the functionality and the data. Even if the structure or the data is private, it still inherits it. That's something novices tend to forget or not to learn. So the derived class object has the same data as the base class plus more, and here we see the so-called object layout, the memory layout. So the base class data and the derived class data. So as I said previously, it's always more. So the account data is not accessible to the credit data. You don't need to access it because we've got ways of accessing it indirectly. So this is what we have to do. So just a forward reference, if we're going to create a derived class object, we have to initialize its base class data and we have to initialize its derived class data. Okay, so once you've inherited, all the member functions which you've created in the new derived class are accessible, but also the functions in the derived class are also accessible. So here's a diagram. Okay, we now want to get to the next stage. We're talking about constructors. As I've said before, when you're creating a derived class object, you have to initialize the base class data and the derived class data. And then the order is as follows. When you create the derived class data, you first of all have to create the base class data, and after that you actually implement the derived class data. You initialize the derived class data in that particular order. When the objects go out of scope, it's in the order of first the derived class data gets cleaned up. The data could be on the heap as well, and the base class data. Okay, how does it work? How do I actually implement the constructors? So we're not talking about constructors because constructors have the sole responsibility, it's a single responsibility principle, to initialize their data and nothing else. Otherwise you might get into problems. He's trying to do all sorts of funny esoteric stuff. So here's my credit CPP. So the default constructor in the credit class, I've explicitly called the default constructor from account. So whatever default data which is initialized in account will be just called. And of course it's blank at the moment. The extra data which corresponds to the credit class will be initialized here in a moment. Let's say in the base class, well, I want to in the credit class I want to initialize a credit object given an account number. So I just call the base class constructor with account number. So you see here, I don't need to have from my derived class access to the base class data. Some people do it by making the data protected or public or something. It's not necessary. All you need to do is just call the corresponding or the appropriate constructor from the base class of the base class from your derived class. So that's very useful. As we said before, it's only for constructors, the colon syntax. So we're finished. So when you create a derived class, you want to create a number of constructors, of course, but the data, the responsibility for constructing initializing the data from the base class is in the base class itself, and in particular its constructors. So you, in the constructors of the derived classes, you call the constructors of the base classes, and that's the way to do it, using colon syntax. And the other ways are less optimal. So here we are. Copy constructor, that's a tricky one now. So what's a copy constructor of a derived class? In particular, the credit class here, which is derived from account, of course. So by definition, the copy constructor takes a reference, a const reference to an object of the same class. So that's the way you do it. It calls the again via colon syntax. We said that already, but basically we call the account with the source. Wait a minute, there's another problem here, because source is a credit object, but accounts know nothing about credit classes. They only know about accounts. But the whole point about the inheritance is a credit object behaves in all respects as an account object. In other words, in general, a derived class object is always a base class object. Right? Just to convince yourself, if you've got a hierarchy of animals or something, to take a more silly example, the base class is animal, and the derived class could be mammal. So all mammals have blood. So I mean, a mammal is an animal in all respects. So this is the very important, and people tend to get confused. So source, of course, it is a credit object, but it is an account object at the same time, as I've said, because the relationship is our relationship, and yeah, in that respect, it's okay. So the as far as the data in the account data are concerned, this guy is initialized, but of course the data in the derived class has to be initialized here using the open space I've left here for your initialization. So the copy constructor copies the account data from the base class over to here, and the specific credit data must be initialized in the body of the corresponding constructor in the derived class. So here we are. Enough of discussion. Here's the answer. So I have a copy constructor. Assuming I have a credit member data in my credit class, I just call the base class copy constructor, and I just initialize my specific credit data in the derived class. That's more or less it. It's very important that you get it right, otherwise it's going to give big problems. Now, next step is overriding functions. What do I mean? I've got some function in the base class with a certain signature. What do I mean by signature? The function name, the input arguments, the return type, whether the function is const or not const, const input arguments, references, everything has to be the same in the derived class, because otherwise it's a different function. So we can declare the same function name in the derived class and give a body, of course, and we can call it. If a function is not overwritten, it's just inherited automatically from the base class. So here's an example. Let's say you've got a account class with a display function to display the information in your account. So that's just for any vanilla flavored accounts, so it's in the base class. The derived class also has its display, because you want to display the information pertaining to a credit class. So what would you say? Well, I would like to, of course the account stuff is general, the account number and so on, the amount of money I have, but the credit limit I want to display as well. So what we do is the following. The display function, which is also an account, we rewrite here. So we have a credit display. In the body of the code is he actually calls the display function in the base class explicitly. That's quite useful. So we're actually using the scope resolution operator to say run the display function in the base class account. And there is only one base class, so we just call the function here. And of course, in the display function of my credit class, I would like to just print my credit limit. So when I create a credit object and I call this display, this is the function which will be called, and not the function of the base class. So let me go back to my original diagram. yeah, here we are. So in this case my derived class was the credit account, class. Base class was account, of course. Base class, my f in this particular case, was a display. So the base class has a display function. It's a default function. And the derived class will also have a display. So when I create an object of the derived class, I call the display function, in this particular case the f, it will call this function here, and not the base class function. So that's a way to override, to customize your behavior. So certain functions in the base class you don't like, or you want to customize, you can actually rewrite the functions in the derived class. Okay, so where are we? Here we are. Okay, so what is not inherited? Constructors are not inherited by default. So you have to, basically, to make a long story short, you have to rewrite your constructors in derived classes. The structure is not inherited. That's for later on when we get to polymorphism. So if you've got the let me go back to my situation here. It's a very important one. If I've got some memory here on the heap here, and memory on the heap in the base class as well, under certain circumstances the heap will not be cleaned up. So you've got a memory leak, and we'll solve the problem in the next section. But the structure is not inherited. Operators are also not inherited, in particular the assignment operator. So if you have an assignment operator in the base class, you should really overrule it in the derived class as well. Friend functions are not inherited because it's not part of the inheritance mechanism. So you've got lots of friends in the base class, you have to write the friends all over again. Okay, partial operator inheritance. So the assignment, the equality operator, for example. So let's say I've got two credit objects. These are two objects of the derived class. The operator, you know about operator overloading. The equality operator, this will be automatically inherited from accounts. So you're comparing not the credit objects, but the account objects, which may not be what you want. In the credit, you like to see if the account numbers are the same plus the credits are the same, or something else. So you have to basically override overloaded operators in derived classes. An important one here is the we talked about public and private. We got an intermediate access specifier called protected. So you know that derived classes, compared to just normal classes, have a special relationship with the parent, the base class. So the protected members allow the derived classes to access the members of the base class directly. So in other words, classes, normal outside world classes, cannot access protected members, only the public. So there are three different regions. Let me draw a diagram here again. Protected can be quite useful. We'll see later on. Okay, so we got everything begins with a P. So we got the private. We've got the public, and we got protected. 3 P's. In UML diagrams, when you see UML diagrams, private is normally with a minus. In the diagrams, you see the classes. Protected is a plus, and the public is a plus. It's open to everybody, and protected, I think, is like a hash, like you saw in the preprocessor. Now, so public, here's private, here's public. That's I would say the initial stage is keep everything public and private when you're learning C++. In the computational finance part of the course, we will be actually doing a bit of protected, because certain derived classes want to access the data in the base class directly, matrices and meshing and so on, and we want to, for performance, it's going to be better, because normally with public you have to have get and set functions, so it's an extra function call, but protected can be useful. It's not in your survival kit, as it were, but it's we'll see it later. So now we get to the inheritance, different kinds of inheritance. To be honest, I don't really know anymore what this slide's all about. It's just a piece of syntax, and it's marginal. It's in the 20-80% zone. It just makes life so much difficult. I just use for inheritance just public inheritance, so public account all the way. In the old days, we spent something like a couple of hours explaining all the different scenarios and what goes wrong and what goes right. I think it's just a bit of overkill, and it could be a sign of a design error, which I've seen quite a lot. So we probably don't have these problems. Anyway, so if you don't mind, I would like to skip it. If you see protected and private inheritance, prepare yourself for a bit more work, and the objective is to learn C++ in a decent way. Maybe this is for later on. Okay. Behavior of the derived object. So once I've created an object of a derived class, as I've said before, because it is and is our relationship, the derived objects behave as base objects. They also have more behavior, but they still behave as a base class object. A credit account is still an account. Why? Because a credit account has all the functionality of a normal account. A very important principle is the following. It's a so-called substitutability principle. If I've got a function which expects a reference to a base class, you can call the function with an object of any derived class, which is very powerful. It means you write your code once and it works for all derived classes which satisfy certain conditions. You can assign a derived class object to a base class object, but not vice versa. But we'll see in a moment what I mean here. Okay, so we're finished with the basic inheritance. We concentrated on the actual mechanics of creating a derived class. So just as before, you create a derived class object with a HPP, a CPP file, and you derive it from the base class. You have to reconstruct create the constructors again by calling the constructors of the base class, and possibly operators as well. And yeah, the derived class has extra functions and data. So that's basically it. When we get to the next section, we'll talk about polymorphism, which is like super duper inheritance. But we'll skip it for we'll just wait a moment. Okay, the summary is we overviewed the basic stuff: compile time, non-polymorphic inheritance in C++. When you go from a base class to a derived class, the data and functions are always inherited. You get more, even if they are private. You can't access them, but you get them. So we can get there's no runtime polymorphic switching between derived classes possible. And the feature may or may not be needed on the other hand. So in the next slideshow we'll be talking about polymorphic runtime behavior, which is quite nice, but it has a performance impact. Okay, here's some quiz. Very important that you understand what the colon syntax. What is it? What's the purpose? Why is it better than just saying, okay, just let's make all the data in the base class protected, and all the derived class objects can actually access the data directly. Yeah, it's possible. And some people do it, and some legacy systems have it as well. So is it a good idea? Yes or no? The best thing is to think about when something changes, which derived classes do you have to change? Which member functions which are defined in the base class are not inherited as such by derived classes, or only partially? Is it possible to derive a class from two or more base classes in C++? It's a bit of a research question. It's called multiple inheritance. Is inheritance needed? So if I want to reuse the functions and code of a class, why not just embed the class in a new class and use aggregation, the has-our relationship? Okay, Here's another one. These are to really get you thinking about inheritance. I've got a circle and an ellipse. Some people jump immediately into inheritance. If I've got an ellipse class, do I derive a circle from the ellipse? Or do I have a circle and I derive the ellipse from the circle? So which one? Or neither. A stack type, which we'll talk about in the STL part of the course. A stack is a data structure in computer science, and what a stack is, you pop something from the stack and you push something onto the stack. So if you're working in a restaurant, you're washing dishes, you've got a stack of plates, so you clean the plate and put it onto the stack, or you take it off for a customer. So if do I create a stack class derived from a list class or not? A mathematical vector is derived, so it's a vector in which you've got mathematical operations like plus and minus and inner product, derived from a general array class, which can be an array of anything. Is that a good idea? I've got instruments, financial instruments. Everybody knows what a financial instrument is in the computational finance. I've got an option class. I derive it from a financial instrument. And when you start thinking about how easy is it, basically how easy is it to implement what I'm saying, and is it a good idea? Is it semantically correct? It's an important one as well. And even if it is correct, is it maintainable, etc., etc. So that's the only way you learn. The only way you'll answer this question is by making mistakes and trying it out yourself in general, which is the way we've learned it. Inheritance can be bad, and certainly you see it here. So last remark, when you're talking about inheritance, consider the possibility of using the has-are relationship instead of inheritance. Okay, so we're finished now.